Hi, and welcome to TEMEKO. In this video, we'll continue from where we left off in the previous video. In the earlier video, we discussed why it's important for us to solve internal loadings which occur in the structure under investigation. We also looked at how to solve normal and shear forces in the structure when we cut it into different sections, and how to draw the related diagrams. In this video, we'll continue with this topic by looking at how to solve the bending moment in the sections of the structure where it is occurring, and how to draw a bending moment diagram after internal bending moments are solved. We will also learn about the relationship which exists between the shear force and the bending moment. Let's get started. As you may remember from the video related to the internal loadings, an internal bending moment is caused by the attempt to rotate the two sections of the structure relative to each other around the transverse axis of the section. This kind of internal loading is very typical in structures like shafts, beams, and plates. In order to solve the internal bending moments, we have to first draw the free body diagrams of the structure under investigation, and solve the support reactions if this has not been done already. This was also the case in solving normal and shear forces. After this, we can solve the internal bending moments in the structure by cutting it into different sections at points where there is an external vertical load or vertical support reaction in effect. During the solving process, we just have to remember the memory rules related to internal bending moments so that they will be determined correctly. If you recall, when we are working from the left side of the investigated section, then the positive direction of the moment is the clockwise direction, and if from the right side, the positive direction is counterclockwise. By knowing this, we are able to determine the bending moment occurring in this section because its magnitude is the sum of all the moments which are caused by the external loads and the support reactions. Now that we know how to solve the internal bending moments of the investigated structure, let's see how to draw the bending moment diagram. Generally speaking, we will first solve all the bending moments occurring in the structure at the points where there is a vertical load or a vertical support reaction. And then we connect the spacing between the points with a linear line which corresponds to the nature of the load, usually starting from the right end of the structure. If you have followed the memory rules while drawing the diagram, you should have the diagram in which the moment direction is on the side of the structure to which the structure is bending towards. Note that this applies only for the situations where the structure is subjected to external vertical point loads. In situations where the structure is also subjected to distributed loading, the process is more complicated. This will be covered in the next video. Another important thing that you should remember is that if one end of the structure is fixed, then on this end, the magnitude of the bending moment in the diagram cannot go to a zero value. Whereas if the end of the structure is connected to a pin support like in the previous example, then the magnitude at this point is always zero in the diagram. The reason for this difference is that a fixed support is able to carry a moment around all axes, whereas a pin support does not. There are also a few other important rules for you to know when drawing a bending moment diagram, which are related to the relationship between the bending moment and the shear force. The first observation which you should note is that at the points where the shear force diagram crosses the horizontal axis of the diagram, there can also exist a maximum or minimum value for the bending moment diagram. Why is that? Well, it's because of the fact that the shear force is a derivative of the bending moment. This is called the relation between these two. Notice, however, how the point where the moment occurs, which can also be referred to as the point moment, on the structure can make an exception as to where the maximum or minimum moment can be found. The relationship between the shear force and the bending moment can also provide us with the information related to the behavior of the diagrams and what connects them. Like when the shear force has a positive value, then the bending moment is rising in its diagram and vice versa. Also, at the sections where the shear force diagram has zero values, the magnitudes of the bending moment stays constant in the diagram. This may seem a little bit complicated at first, with all the different rules, but like the old saying goes, practice makes perfect. I encourage you to practice this because, as it was said earlier, the ability to determine internal loadings and to draw the corresponding diagrams is the foundation of structural design. Hopefully, after watching this video, you know how the internal bending moments on the structure can be determined and how to draw the related diagram. You are also familiar with the relation between bending moment and shear force. In the next video, we will learn how to apply the knowledge on internal loadings and their diagrams in situations where the structure is subjected to distributed loading. Thanks for watching and have a nice day.